I don't need a video. Close the choose camera. So I don't want this camera to be hidden. So yeah, we will be starting our studio. So these are the things which I was working on earlier. So I will close this thing and I will start afresh. Our studio login. Loud. So you can use the same sentence to log in into your RStudio Cloud. It's free of cost with some restrictions. I guess you can use for a certain limited amount of hours in a month. But I guess it's more than sufficient for beginners like me, where you can learn. So I'm going to go with a new project. These are a few other things which I've already practiced. So I won't be opening these things. I will be starting a new project, a new studio project. So I will be giving you a detail of how to write a code in RStudio and how to check whether the codes are running properly, how to install packages, and how to know about what the package means, what are the inputs provided in the package. Those are the sections which we are going to uh, discuss in this video. So meanwhile, till this studio gets open, as soon as this cloud, our cloud open up, currently we'll be having three windows. A brief discussion about all these windows and what does this mean will be given in different video. But for short, let me tell you, this is the console actually where the codes are been seen, and actually the codes are been run here. You can see whether there is any error while running the codes or not. This is a global environment where you can see whether your variables are running properly, and this is the section where you can actually see your forest plots and whether the packages are installed or not. Well, all these three windows out of all these three windows, we won't be able to write code in this three. So for writing a code we need to open another a small window which is our script. So yeah, this is the script where this is the window where we are actually going to run our code. So we will be running, we will actually performing the meta-analysis in two formats. First, we are having an Excel sheet over here, which is consisting the details which we will be needing to run our meta-analysis, all the inputs. So one of the method is I can directly, I should say, take a data from this Excel sheet and pay and I would say convert that Excel sheet into this art studio, which is actually known as, I'm not getting that word. Um, I guess I need to edit this sentence, which is known as not console, which is actually known as practice vector data frame. Yeah. So yeah, I can directly convert this Excel sheet into a data frame in this RStudio by installing a package known as Excel. Read Excel one, if I'm not wrong. Yeah, it's Read Excel one, and then I can just upload it from here. I can browse it, choose file, and I can just select the thing which I need. This is the simplest way of converting an Excel file into a readable data frame. But right now we will be following a lengthier way, so that way should also be uh, friendly. Means you should be able to do through that way also. So for running that, let us type the favorite Art Studio script first. That is print hello world, and when I'm gonna run this, it will give me. I hope this will be visible to you. If I can change the position, yeah, I guess I can change the position. Yeah. Let me keep it over here somewhere so that it should be easy for you to watch. So this is the basic thing which we usually do after getting into the R. That is the print hello world. Now let me create a data frame. Mm, Data frame for meta analysis. So I'm gonna name my data frame as meta, and then I'm going to create. I'm going to give it as equal to data dot frame data dot frame. So one of the positive side of using an R Studio or cloud is actually it gives lot of prompt, which is very easy to manage. Otherwise, it becomes difficult whether there is a data dot frame or it's data frame as of such. So at times it becomes a bit convenient using this cloud or cloud. So I'm going to write my code over here. The code will be as similar as it is provided in this Excel sheet. So I've pre-written this Excel sheet into the Word document. So I'm just going to copy paste from here. It's nothing new. I've just written it in a format in a format which is convenient for the R to understand. So I'm just going to copy. There's nothing else written over here. It's just the data which is put in the Excel sheet. I've written the data into the Word. So I'm going to copy it from here and I'm going to paste it. I hope things are good, and whether the things are good or not, it will be only visible once we run the code. So let me run it. For giving you a brief, let me reduce the size of the screen. So what I have written over here is I've created a data frame. I'm going to create a data frame which is named as meta. Well, this the author's name. I've combined this actually. Uh, there are two things which you might be seeing over here. First, this is meta, and then this is something less than equal to sign. And this less than equal to sign is actually means equal to. I can use equal to also over here. So let me keep it equal to. So I've kept equal to, which means this I'm creating this data frame and I'm naming this data frame as meta. Now, what are the inputs I'm going to give in this data frame? It's author, again with an equal to sign, and the C sign means it's combined. Well, as most of us might be aware about that, what are variables and what are integers. As author's name are actually variable, A represents the author's name, and this 2020 represents the year of publication. So there are six publications: A, B, C, D, E, and F. So this is the intervention. Again, I'm going to combine it with using C, and then I'm going to put it. As you can see, it is inside a double inverted comma. So when you're putting a variable, you need to keep it under the character variable. You need to keep it under double inverted comma. Otherwise, the R will not be able to understand whether it is an integer or whether it is a character variable. So the intervention for our demonstration is atorvastatin, a lipid drug which helps in reducing the lipid. Uh, then as per the study, it is saying that atorvastatin is 5 mg, 5 mg, 5 mg, 5 mg, and there are total six studies. Similarly, the comparator is having standard of care as a drug of choice, so it means that it is having RC. Now again we also need standard difference for this comparator. Similarly for the intervention sample size, the intervention HDL mean and intervention HDLST. So let's run this code, and if things are okay in this thing, then we will be able to see a green sign over here. Okay, there is some error. So let us see where the error is. It is saying that the author, in case of author, there is certain error. Let us try to correct it. Okay. Um, So this is what happened in live streaming. So I don't want to edit this. Let it be over here. Let me see what error I am conducting while running this code, so that it will be helpful for you also when you are going to write your own code. Unexpected invalid token in meta equal to dot display. Okay, equal to C. Okay. So, easy method of running this thing is to run individually and see whether it is, because there is an issue with this double inverted comma. Let me try to rewrite this thing because I wrote it in the Word format, so maybe the Excel is not accepting it. So let me write it. Yeah, so I got the issue. So if you are planning to write all this thing into your Word document, try not to write it. At least the character variables in a double inverted comma. Try to write directly in the RStudio. I don't know why, but this double inverted comma, it's the reason why we are having an error right now. So let me correct that. Yeah, it will take a bit of a time, but it will be a good learning for all of us. It should not be. Okay, this is something I made an error over there. Where is it? Okay. God. Okay. 1, 2. Rewrite this. Okay. This is what happened when I actually writing the code without any editing. Combine. Now let us try to run the data frame. Let's put a sample. Samples. Okay, yeah, we did an error over here. I forgot to put a comma so that the author understand that this is a separate entity, intervention is a separate entity, comparator is a separate entity, and this all a separate entity, and it should be separated by comma. Now let us try to run it again. Okay, where is it? There are certain signs which art does not consider. So we need to take care of those signs. But again, try to run. Yeah. So as I was saying, so this was actually a live demonstration, which all things which we should take care while running code or creating a data frame in R. And as you have seen, if I wrote down all the things previously in the Word file, and then I was just copy pasting it over here. It was not working. Why? Because this inverted comma is something which was not being accepted from this word in this R. The second thing which we learn is that we need to put a comma after each variable. Means this is a variable with an author with all the details. Then when if I'm going to put the intervention detail, I need to put a comma before starting those things. Again, there are certain signs which the R doesn't consider. As I was earlier putting a slash as an mg per dl, but R Studio was not considering that sign. So those are the certain things which we need to take care of while we are actually coding all the things into the R. But when we are converting this Excel into a data frame, at that time those things will not matter. We will see into it a bit later. So this data frame is been created. Let us check how the data frame looks like. So yeah, let me zoom it a bit. So this is our data frame, which is having the author's detail, the intervention detail, the comparator sample size, the comparator mean, HDL level, the comparator HDL SDL. I mean, it's SD, not SDL, it's standard deviation. Similarly, for the intervention sample size, intervention HDL, and intervention HDL standard deviation. Now, straightly we'll be jumping into conducting actually meta-analysis. Conduct meta-analysis. To conduct the meta-analysis, we are going to use NetMeta, I guess. The package. Let me check whether the package is over here. The package name is Meta. I don't think the package is installed over here, so let us install the package. Install the packages and Meta, because that's the name of the package. So, so it is getting installed. Okay, we take a minute or so before getting actually installed. That is installing a new version. We could have done it from here itself. I guess the meta would have been installed over here. Yeah, this is the meta which got installed, and that meta that also got installed. This is something which has been installed even though I didn't ask for that. So let's us know a bit about this meta package. If you want to know anything about any detail about any variable or any code in RStudio, you can just write question mark before that, and then you can write that package, or I would say that command, and just run it. This I will give you a brief about that topic. It's very handy. So we are going to use meta count because our data is a continuous variable. So we will be using this meta count to run meta analysis. So let us know a bit about this meta count also on ETAC. It is a package which comes along with this meta. So this is our meta count, and we will be using this. This is all the details. This is I will be explaining all this thing in a short. So we won't be using all the things which has been provided over here, but yeah, we will be using few of them. So getting again using it. So yeah, let's run meta. Let's run the page for the so we will be naming it as MA. Let's keep the name as MA equal to meta count. I guess this is shouldn't do some meta count. Yeah, shouldn't do that. Anyway, doesn't matter. Now we need to put the data for us. Means the data means from where this meta count is going to take the variables. So for us, we named it as meta. You can name it any whatever variable you want to. But we'll be take care of the whether it is case sensitive. Case sensitivity is very peculiar in this R. So we need to take care of those things. If it is META, then you need to write in that format also. And if you are going to use small m, the R will not be able to recognize it. Now to run a meta-analysis, few things are very common. That is, first you need a data set. Second, you need the n, that is the sample size. Then you need a mean. Then you need standard deviation for intervention and comparator. So I'm just going to write that thing only. That is n means the sample size for experimental arm. So it will be meta dollar it's a simpler way to get the details from here. So the intervention from us it's this, that is in sample comma mean dot experimental equal to meta dollar again, it would be sp dot experimental equal to meta dollar this intervention HTL standard deviation, comma, let's continue the next line. Similarly, n dot comparator equal to method dollar comparator sample, comma, mean dot comparator equal to. As you can see, this R is a bit smart. It's giving me the things which I need because I've already entered the mean for experimental. It's giving me just the mean for comparator. So it's good using this RStudio Cloud. Uh, then it will be, I guess, mean comparator, comma, sd dot comparison, meta dollar, no, sorry, it's meta not mean, meta dollar HDS. So this is the basic thing which you need when you are writing a code for this meta-analysis, which include the data set from where you're going to get the data, the and the sample size, the mean, the standard deviation for both experimental arm and for the comparative arm. So I'm going to run this code. Let's see whether it's gonna get run. Yeah, so these are the blue things which mean the code has been run successfully. So let us try to plot the forest, and then so this is the forest plot. It was so simple with just two lines of code. You were able to get a such beautiful forest plot. So let me give a brief about it very briefly. We need to change a lot of things over here, but even then, let's see. So we are having both common effect model and random effect model. We are having the details of study in which the actual name of study has not been reported as of now. So we need to check for those things. Usually in a forest plot, we don't have both common effect and random effect, so we will be going with a random effect model because usually the studies are not very similar. Again, we are having a mean difference, but I want the standard mean difference, so we will be changing this mean difference to SMD. And yeah, this is gray, so I want to change the color of this what's called diamond actually. And I want something written over here in the below of this uh, figure, that is where does the intervention actually is helpful, or whether the intervention is providing a positive effect and actually improving the HDL value or not. So through looking into this forest plot, it's pretty clear that yes, uh, the intervention is actually helping in improving the HDL value, which is actually good. But this is just an example, so obviously there will be a lot of differences when we are actually going to take live studies and conducting a meta-analysis. So getting back to the code, so now there are certain fillers or non-ink thing which we need to put in this in this section so that the forest plot is more approachable and a bit user friendly. So let me write a different code for it. Uh, non. I'm just gonna copy paste all this thing from here. I will be writing it ma underscore one, and there are a few things which I'm gonna add over here. First, I want to add labels. Dot label equal to meta dollar author. No, I don't want common effect model. I need random effect model only. So random equal to true, common equal to false. So I don't need to write the entire true over here. I can just write capital T or capital F. So it will the R will understand that I don't want common effect model. I just need the random effect model. Okay, few more things. As you can see over here, this control SD is having lot of decimals of lot of values after a decimal. So I don't want that much of those decimal values. So I will be converting it into digit dot SD. I guess this is the right code for it. Um, two. I guess so. Let me see whether I'm writing it correctly. Okay, let's try to run this. We will get an error if there's no error. So it means that the digit after this, for this standard deviation after the decimal point, there will be only two digits. Few more things are there which I want to edit, but I won't be doing it right now. I will be doing in the next subsequent step, and I will be converting this Excel sheet into this R project, R Studio. Now let us again run this forest plot. Was there any change? Okay, sorry. Yeah, there will not be any change because I need to rewrite it as well. It's pretty clear that this SD didn't change. I have to check where did I make a mistake. But yeah, the study has been changed. The study name has been provided over here. The random effect model is only there, not the common effect model. And currently, I have not changed this mean difference into standard mean difference. I will be changing it in a subsequently. So these are the changes which has been conducted. Let me see where did I made a mistake. Digit digit.st is was it correct or with something value dot. So yeah, you get used to it. You get used to that prompt, and if you don't remember it, it becomes a bit difficult. I think digits dot st equal to two. Let me check. Now let me check. Don't know why it's not getting worked. Uh, yeah, I guess I need to check it again. Where is the issue with the digits? Seriously, I'm not able to recall why it's not working. Hmm. So yeah, so it works. Should have worked. Digits. Not. Okay. No, it's not getting worked. I'm not sure why it's not getting on. Let's see when after running this, after getting this Excel into this arm, we will try to check why this SG thing is not working. Suppose that we need to change the color of this diamond, and I don't want mean difference. I want standard mean difference. So yeah, let's get back to it. Excel and Excel. To, for that, I need to install a package. Install packages. Read Excel, I guess. Read Excel one. Okay, it's not read Excel one. Let's read Excel one. Who is writing correctly? It's okay. It's just read Excel, not one. Oh, there was a mistake which I was selecting. Read Excel. Okay, now it's getting loaded. Let's wait for a minute. So for that, I need to get import dataset from Excel. Whether I can use this code, let me use the code, or I can just do one thing. I can browse it. It's over here for meta-analysis, this Excel file. So let's not use it. Let's write the code so that it will be convenient for us. Okay, don't want this. It's over here. It's somewhere over here. I'm not able to do this. Let us write the code that will be more convenient. So let me copy paste it. It's already installed. I don't need this. I don't need data set. I need it. Right. Let's write it as forest. Forest and not write it as. The code is read Excel, and then I need to write copy this thing from here. Ultimately write it. So comma for meta analysis dot Excel. But anyway, so this is a view option. I don't need it. And we're getting back to this untitled section. Let me print it. That's a bit easy. So yeah, over here you can see this is. So what problem which we were having earlier is that we were not able to use this sign, the slash sign when we are writing the code, but when we are converting this Excel into this R, this code is being accepted by the R Studio. Okay, so all the things are same. The author's name, the intervention, the comparator, the sample, the mean, and the comparative HDL level, and there are a few more things which is not been visible over here. But yeah, we can check it over this side. Yeah, over here you can see it very clearly that all the things which we actually did it when we were typing this code, this happens. And so, yeah. Now, when we were running this code, this is Meta, it was having similar kind of details, but it was visible within this frame. But this Excel file is not visible. So no issue. The details are exactly the same. So let us try to run those things which we are not able to run in this section. So let's run meta-analysis for Excel. Meta-analysis from Excel. Now let us write the code again. Let us give the variable name as g equal to metacount data equal to currently it's X, comma. So I cannot copy paste it because the things are different over here. X dollar, it's intervention, comma, me dot e, default, I don't know this, equal to X dollar, intervention sample, comma, no, it's not. Sample should be n dot e. Now me dot e. Yes, default means e, but we won't be using the default thing. Uh, X dollar USD, XT dot e, X dollar. Enter. Yeah, so we put the mean for experimental and standard deviation for experimental. Now we need it for the comparator. Now n dot c equal to x dollar comparator, comma mean dot c x dollar LTL mean, comma sd dot comparator x dollar standard deviation. Now let's add all those things which we have already added over here. That is stud lab, and just we need to take care of this digit somehow. Let us see what we can do. So we need to change the stud lab because now it's not the methods. X author. Is it the same author or authors? Yes, authors. Yes, is there. You did put an enter mark where it is random and this all. You copy paste it from here. Okay, then random true, common, false digit. Somehow it's not working, but let us see why it's not working. Uh, sm equal to smp, comma. The code for that was method. Okay, I need to put it in the notebook. Smp standard difference. Uh, method dot smp is equal to double inverted comma. We are going to use. Now let us check. Oh, now let us check whether this is working properly or not. Okay, there we are creating an issue. Any sample, it's integer, it's st, nc, comparator, st. Why it's creating an issue? Error in meta count, data is equal to x, mean e is equal to intervention, mean and e. Okay. Okay, that's where we are creating error. Okay, the intervention actually here means that over starting and this thing. Yeah. Okay, okay, I got the point. Why is it creating an issue? It's not going to be an intervention. It is supposed to be uh, intervention sample. Now, okay, okay. These are the things which you need to take care of. It's my mistake, but yeah, it will be a learning for you guys. So I just need the sample size first of all. So this is not a sample size. I need to rewrite a code. Dollar sample size is intervention sample. Now again mean. The mean is intervention HDL mean. Standard deviation is intervention HDL standard deviation. The NC, that is the number of sample and comparator. It's not. It has to be changed. Dollar comparator sample and mean comparator is comparator HDL mean value. HDL comparator is X of comparator HDL standard deviation. Okay, now let us try to run this. Yeah, it ran perfectly. So now let us try to create a forest plot for this. Somehow this digit thing is not working. I don't know why. Yeah, so it got converted into standard mean difference, which was earlier a mean difference only. Yeah, there are certain changes. Let me give you a live example of this. Uh, yeah. So what you can see, if it was a mean difference, it was coming at 16.15, whereas if we are going with the standard mean difference, okay, at a time cycle window will only be open. If we are going with the standard mean difference, the value comes up to be 5.15. So there's a huge difference, nearly 12 point difference. So yeah, it depends on the author which method they are going to follow, whether it's going to be a mean difference or a standardized mean difference. It depends on the author who is actually running this systematic review meta-analysis. With this forest plot, we also need to check the publication bias with the funnel plot. Funnel, I guess this is the funnel. This is the funnel plot. So yeah, most of our study are out of this 95% confidence interval, so it's highly biased. If it won't have been biased, then almost all the study would have been inside this 95% confidence interval. So that's actually what happened when we are just writing it randomly. But when we are actually taking values from an original study, then this thing won't be happening. At most of the time, your studies will be within this funnel of 95% confidence interval. So let us just do few editing over here with color dot I guess diamond. Should we color dot diamond? Okay, it's not color, it's call. Yeah, call dot diamond value amount. Yeah. So let us just make it blue and call dot label square lines. You can play along. It's perfectly. I feel it really fascinating when actually able to run all those things. So yeah, this is blue color diamond for us, and these are the black studies which are reporting their weightages. Uh, Higher the weightage, more value has been given. Usually, the weightage depends on the sample size. So, greater the sample size, greater the weightage has been provided. What this the description of this entire forest plot will be given in a different video because I don't want to make this RStudio tutorial lengthy. Anyway, it has been a bit lengthy because of my mistakes which I was doing while writing the codes and all. It's character string, common effect, no, headline 2, text per second additional and put flow meta analysis result. Let us try this thing. Could you, okay, connect driver and column. Okay, okay, sorry, I wrote 2 equal to 3. So you need to do a trial and error thing. Then only you will get a perfect shot. Okay, again it's just below it. I don't want it over here. I want it somewhere over here. So let me recheck how to get that sentence written in the perfect place. It's this. Get a string label weight of common input model, common tool for this time, random. Yeah, predict. Yes, it's predict. Uh, Character string used in the plot to label the prediction interval. I don't think so. Below meta-analysis result. Now let us try to run. I hope this will be in the perfect place. It went. Now I'm not even able to search it. Okay. Let us give it a try over here. Why it's not working? What is the actual code has to be written so that it should be below its diamond? Uh, hmm. Again, I'm not able to find out why it's not working where it has to be put. Um, Subgroup. No, I don't want a subgroup over here. That is still the level prediction algorithm. You can keep it below this as an add line below meta-analysis isn't, but I don't want it over there. But yeah, yeah, that's what we usually face when we are actually running a code. So this two things were not able to work. That is the digit dot sd. It's not. Still, it's having more than two digits after the decimal, and this is the text which is not able to work. So yeah, in the next video, I will definitely try to sort this two things. But for timing, let me write it like add line so that at least it should be below that meta-analysis figure over here somewhere that it favors the intervention. Yeah, it actually favors the intervention. So if we're going to interpret it, it will be that the experimental arm which was atorvastatin was able to increase the HDL level by 5.15 mg per dl compared to that of control, which was significant, as you can see from the 95% confidence interval. So yeah, this is how a small description of how you predict this forest plot. And two things which I will be sharing in my next video is how to add a line just below this false plot and how to get rid of extra digits after the decimal point. And I will try my best to keep the video as short as possible because the lengthy video, the distractions are there are a lot of distractions which can come across while going into such a lengthy video. So yeah, thank you all for your patience. I hope you might be having a lot of doubts, and I will be very happy to receive your doubts, and I will try my best to resolve it. Meanwhile, we will be learning all the steps about meta-analysis and how to interpret this forest plot. And so, thank you so much. I will try my best to keep you posted. Thank you so much.